Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So now we're going to work on problem 71 from chapter 8. In this problem, we're given several reactions and we're asked to determine which are redox reactions. And for the ones that are, we need to determine what's the oxidizing agent and what is the reducing agent. So the first reaction which we're given is lithium solid reacting with oxygen gas to form a lithium oxide. So the question now is we need to go ahead and check the oxidation states for each atom. So for lithium, on the left side, both are in their natural state, no charge, so both have a 0 charge here. And then on the right side, lithium has a positive 1 charge and oxygen has a negative 2 charge. So we see that the elements are changing their oxidation numbers. So this is a redox reaction. And so the question is, what's the reducing agent? What's the oxidizing agent? So the reducing agent is one that is giving electrons. That means it's losing electrons itself. So lithium is going from 0 to positive, so it's losing electrons. So that means it's being reduced. It's the reducing agent. And oxygen is gaining, which means it's being reduced. So that means it's the agent of oxidation, or the oxidizing agent. In part B, we're given magnesium solid plus iron 2 plus aqueous, and this is producing magnesium 2 plus and iron solid. So here it's pretty easy to see the change in charge or oxidation state. So magnesium here is 0, iron is plus 2, magnesium goes to plus 2, and iron goes to 0. So this is a redox reaction. And magnesium here is losing electrons. That means it's the reducing agent. It's reducing the iron. And iron is gaining electrons, so that means it's oxidizing magnesium. So in part C, the reaction which we're given is lead nitrate. And this is reacting with sodium sulfate. And this here is producing lead sulfate, solid. And 2 sodium nitrates. So we can go ahead and check the charge on each of these. On lead, we have positive 2. On nitrate, we have a charge of negative 1 for the anion, the whole ion. Oxygen is negative 2, which means nitrogen has to be positive 5. Here we have the positive 1 on sodium. Oxygen is negative 2. Sulfate is negative 2. This means that sulfur has to be positive 6. And then we see the same thing on the other side. It's plus 2. Sulfate is still negative 2. Sodium is +1, nitrate is still -1. These numbers haven't changed, so this is not a redox reaction. In part D, we're given HBr plus potassium hydroxide producing water and potassium bromide. So we look at the oxidation states. Hydrogen is +1, bromine's -1, potassium is +1, hydroxide is -1. So hydrogen is +1, oxygen is -2. For water, we have +1 for hydrogen, -2 for oxygen, +1 for potassium, -1 for bromine. We see that no element changes its charge. There is no change of oxidation state here. So this is not a redox reaction.